1686. A manuscript by Newton was on the desk of the Royal Society. At that time, the society was broke. They awkwardly admitted, "We can't afford to print it." They had spent their budget on a flop called The History of Fishes. Modern physics almost lost its chance to be printed because the manuscript was Mathematical Principles of Natural Philosophy. In the end, astronomer Halley paid the printing costs. Later, when the society gave Halley the unsold copies as his salary, in that financial mess, the universe of modern physics was born. But to understand why this book matters, let's rewind 20 years. 1666. Plague swept London. 23-year-old Newton retreated to his family farm. Legend has it that on a dull afternoon, a ripe apple fell to the ground. This simple sound sparked a question in Newton's mind, which was more intense than the plague. He asked himself, why does it always fall? Straight down the earth? If the tree grew even taller, as tall as the moon, would the same pull act on the moon? If so, why doesn't the moon fall down? He imagined a cannon on a mountaintop. Fire it, and the shot would trace a parabolic curve to the ground. But with enough gunpowder, and if the shot moves fast enough, so fast that its curve matches the Earth's curve, then the cannonball would keep falling, but never hit the ground. And the moon is that cannonball. Before this, heaven and earth were separate. Things in space moved in perfect circles. Things on Earth moved in straight lines. But Newton found the force pulling on the moon and the apple are the same. It just weakens fast with distance. Double the distance, the force drops to 1/4. This is the famous inverse square law. It's like an invisible chain, connecting the everyday apple to the sacred moon together. After the Principia, scholars pushed the idea further. The universe isn't a divine playground. It's a precision clock. Gravity is the mainspring. Given an initial state, the cosmos ticks forward precisely every second. To prove it, people started predicting the future. 17 and 5. Halley used Newton's laws to predict a comet would return on Christmas around 1758. He didn't live to see it, but the comet arrived on time. Halley's comet proves that Newton can predict time. Next, a discovery further proved he can map space. In the mid-19th century, astronomers noticed Uranus wobbling. Its orbit was off. Is Newton wrong? No, it's impossible. LeVerrier believed the error was our eyes. There must be an unseen planet, hiding in the darkness, secretly tugging Uranus with gravity. In 1846, using only pen and paper, LeVerrier calculated an unknown planet. That evening, the Berlin Observatory found Neptune with telescope. It was only 1 degree off from its predicted position. It's the most arrogant, glorious moment in science. Human was able to calculate the universe merely within a paper. Pierre-Simon Laplace even boasted that if a man knew the positions and speed of all particles, he could calculate every second of the time. When Napoleon asked, "Where is God?" according to an anecdote, Laplace replied coldly, "I don't need that hypothesis." But just when you think that you are holding the truth, the universe would give you a new lesson. Blinded by his success, LeVerrier turned to Mercury. Mercury's orbit isn't a closed ellipse. It's like a rotating pedal. Every century, it advances 43 arcseconds more than Newton predicts. LeVerrier tried the same trick. Another hidden planet must be tugging Mercury. He even named it in advance as Vulcan. However, decades had passed, and telescopes found nothing. Vulcan actually does not exist. So, this time, Newton's math failed. At the beginning of the 20th century, in a Swiss patent office, a young man started daydreaming. Albert Einstein got a new idea that he would later call the happiest of his life. If a person falls from a roof, can he still feel his own weight during the fall? He realized that if you're in a closed elevator and the cable snaps, you will float inside, like in space with zero gravity. At that moment, you cannot tell if you're falling toward Earth or floating in deep space. Conversely, if an elevator accelerates upward in space, you would feel like your feet pressed to the floor, like being pulled by gravity. So, gravity and acceleration actually feel the same. Therefore, gravity isn't just a pull force. It is a state of motion. To describe this, Einstein spent 8 years. He got math help from an old classmate. In 1915, he delivered the theory of general relativity. Einstein proved that space is not stiff. It's flexible, like a fabric. The sun holds Earth because its enormous mass warps the sheet into a dip. The Earth isn't actually being pulled. It's just moving along the curved dip in a straight line, appeared as if it's spinning. Matter curves spacetime, and curved spacetime guides matter. But Einstein needed proof, so he bet on Mercury's orbit. He recalculated Mercury's orbit with new math, and that troublesome 43 arcseconds appeared naturally. No Vulcan, no extra planets, just Mercury, which is so close to the sun, where space is most curved. At there, Newton's math didn't work. 1919, Eddington observed a solar eclipse. He confirmed starlight bends near the sun, just as Einstein predicted. The Times ran the famous headline, "Scientific Revolution, New Theory of the Universe, Newton Overthrown." Was Newton truly overturned? Not really. His laws still launch satellites into space, and Einstein didn't win in the end either. His theory breaks down at the singularity of black holes. This may be the cruelest truth. About science, we can never get the full picture of the universe. We only get closer to its outline. Every time we think we have locked everything up with a perfect rule, the universe always slips away through the crack with a tiny anomaly. As Newton said, we are only children playing on the seashore. As centuries passed, we pick up one beautiful shell, then another. But when we look up, the ocean of unknown truth is still there, surging and silent. Yet science's greatness lies in this. There will always be another child, willing to drop the shell in hand, jump into that deep blue, and search for another answer.